32-bit the addressing format. It's a 2-level. Okay. What if the 64-bit? Actually, 64-bit, we have the flexibility to represent the address because we have the 64-bit. So we can have the bigger size of the page we can represent. So I think that this is the most the level of the hierarchical management. So one outer, second outer, and the inner. So 3 level of the page table, then finally offset. Hash. Okay, what is a hash?
Key and element.
Data structure. Then, what kind of data structure? What is the most popular hash function? Keep in mind modular. If you don't remember any hash, what is a hash? Keep in mind modular. Modular, 10 modular by 5. 0. And 9 modular by 5. 1,230,000 whatever the 2 modular by 5. So 2. Right? So which means hash function can make very, very long, complicated data into simple one. It doesn't matter whether that is the number, that is the ASCII, and that is the character. You can just make the simple number. Most popular one is modular, but you can have the many different hash function. Okay. Then hash. Another question. Hash function is one way or the bidirectional? One way or 2 ways? Which means can you restore the original value? No, it's one way. So that is the reason it's used for those security purposes. But at the time you need to have the public key and private key after you apply. Otherwise, no way to restore. So that is a hash. So many of the time we can use the hash because for each hash key we can create a hash bucket. Hash bucket is the storage to keep the data that has the same hash key. It's the same thing. So for the number of pages we can apply the hash, the function. Then this one is the one hash key. One hash key has you can keep the data in the bucket or using linked list. Then until you find. So if you have the same value has the output of the hash function is the same, so you can go to the hash key. Then finally you can find this one. I'm not going to mention about the details of the hash, but definitely you need to know if you are graduating from the RCS, you need to know about the hash. Hash actually used a lot. It's very simple, but performance is very good. So you don't have to use complicated indexing algorithm or whatever. It's very good, reasonably good speed. So we can use a hash table. Inverted page means so. Maybe okay, so inverted. So far we managed the page table by what? Page number. Logical page number. Then search all of this. In case we had a huge number of page number, we can do the hierarchical, or we can do the hash to speed up. What if we organize because each process has each page table. So we can organize such a page table by the process ID. So address format include the process ID. That process has what? A number of the pages. Okay. The process ID has 1, 2, 3. Then this 1, 2, 3 has the 1, 2, 3. So physical number is 3. So in other words, for example, this one has the 0, 1, 2. Okay. Then 0, 1, 2 is mapped to 7, the 0, 5. So process ID is 10. So address format is a process ID 10. Okay. Then for example, page table has the 10. What is the 7, 10, 0, 10, 5, and the process ID 11, and so on. So when you search the page frame, so one process 10, you can go to the page table for the process ID 10, and go to the for example, the 1, you'd like to search the page frame number for the logical address 1. So 1 is 0, 1. So 0 will be returned. So it is organized by what? It's not page frame, and it's not ordered by the page number under your program. Instead, page frame. So that's the reason it's called the inverted page table. Another example of the inverted. Sometimes the inverted approach provide better performance when you search the data. Like for example, Google search engine. How does the Google search engine? By the way, so it was the 1995 when I used the internet first time. Okay, I got the email address from the University of Hawaii when I visited the elder sister. Then they explained what is the HTML and so on. It was really impressive at the time. Then they explained Yahoo. So when Jerry Yang, I think it's 1990 when Jerry Yang opened the website to how to search. Okay. When the Jerry Yang implemented the first search engine is very simple. Use starting from the one page and using the hyperlink and connect and save the HTML and check how many the link. Then visit the web page and save and keep all the pages. That is called crawling. So like the crawl, the basement or the attic. So crawl all the web page and save it. Problem is how to search the document. You need to keep the keyword, right? So keyword by page number, but that takes a long time. So instead, each document has number of keyword. So it's an inverted approach. Then you can search this keyword, but the index is the page document has this one. Then sometimes you can compare the page by page, whether this is a similar page or the different page. It's called the document indexing. So it's inverted approach is a lot inverted the document indexing also. Okay, so you can quickly go over the example of the such the memory management in the real system like the Intel and so on. Next class, we will have the last chapter for the virtual memory management. Here, even though we are using the page, that doesn't mean that we increase the capacity. It's still the same physical memory size. So no way. So to address that problem, we are going to use the virtual memory concept. So that will be the last chapter of the probably semester. Okay, thank you, and see you next week.